In ArcGIS Pro, the split line and vertices tool is only available on an advanced license. But here we're going to take a look at how we can use ArcPy and the basic functionality to recreate that tool for use on a basic license. Let's check it out. We'll first pay a visit to the documentation for the split line at vertices tool that is in the data management toolbox. And we can see that it creates a polyline feature class by splitting input lines or polygons at their vertices. Now here we are only interested in lines, and we may visit polygons in the future. We take a look at the usage. The attributes of the input features will be maintained in the output feature class, and the following fields will be added. So we're going to have an ArcFID that stores the feature IDs of the input features, and ArcSequence that stores the sequence number for each output line following the order of the segments from the starting vertex of the input feature. If an input line only has two vertices, the line will be copied to the output as is. We scroll down, we can take a look at the parameters. So here we have the syntax for the tool, which is arcpy.management.splitline, and it has two parameters, in features and out feature class. The in features is the input line or polygon features. As stated, we are only going to account for line features, and the out feature class is the output line feature class that we're going to store as a feature class on disk in a file geodatabase or a shapefile. Let's go over to our script and walk through it. Here we have a list of all the geoprocessing tools and functions that we're going to use from ArcPy to recreate this tool. Not a huge amount of them. Once more, we have the syntax here we want to copy with in features and an out feature class. Now this workflow will work from ArcGIS Pro version 3.4 and 3.5, but you will probably have issues from earlier versions. We first want to capture our user inputs. So we have our in features, which will be our linear feature class, and we have our out feature class, which will be the output feature class file path to our linear feature class. And when we recreate this tool in ArcGIS Pro, we can grab the inputs using the get parameter as text functions. So this will grab the first parameter and this will grab the second parameter. We have several tool object requirements. We need the SRS ID of the input feature class so we can apply it to the output. We want a list of the input fields in order, minus a few field types. We don't want blob, geometry, global ID, GUID, OID, or raster. And we'll store the field names in the in field names variable. We are going to append the shape at token to the in field names so we can access the geometry for each feature. However, we are going to remove the shape underscore length field, which is a system maintained field by ArcGIS Pro. So we'll remove that from our in field names if it exists. We will need the OID field so we can populate the orig ID in the output field so we can mimic the tool as closely as possible. And we will insert the OID field name to the start of our in field names. Now that we have our fields lists in order, we have two other required objects here. The segments list will hold information for all line segments to create in the output. It will be a list of lists containing attributes and geometry that individually define each line segment. In order to get our line segments, we are going to have to get each individual vertex and know which line that vertex is associated with. So we're going to create an empty dictionary, and this dictionary will hold the key of OID, so the object ID for each line in the feature class, that is each line in the input feature class, and then the value, which will be a list of vertex points for each line. We'll come back to these two lists as we go through the workflow. First up, we want to get the vertices associated with each line. So we iterate through each record in the InFeatures feature class using a search cursor. And here we're only interested in the OID and the shape at token, which will return the geometry for each feature. So for each row in the cursor, which is for each feature or record, we're going to create a point list. So we'll store each point geometry associated with that feature where each point represents a vertex along that line. We now want to dig into each part of the geometry. So row -1 is the shape@, token. So for each part in our geometry, we're going to access each point and create a point geometry. So if you think of a line, we'll have a start point that will be created as a point. We then move on to the next vertex, create that as a point, add it to the points list, onto the next vertex, make that a point and add it to the points list. So here we are appending each point geometry to the points list. Once we have all the points for that line, we're going to create an entry in our Vertices dictionary where the object ID is the key and the value is that list of points that we just created. So we go back up to our Vertices dictionary. We're going to have each linear feature stored in this dictionary as an OID for the key, and then a list of point objects that represent the vertices that we converted to point objects. Now we want to split the lines. Once more, we are iterating over each linear record using a search cursor. This time we are using our in-field names. As we split each line segment, we want to maintain attribute values. So for each line in the cursor, we're going to get the start point of the line as an X and Y tuple. Then I'm going to dig into our Vertices dictionary where we use the object ID to grab the correct vertices for each line. So our point selection variable here will be a list of point objects that represent the vertices for the line in this iteration. We create a list called distances. We're going to get a list of distances that each point represents along that line feature. So for each point in our point selection, which is each vertex along that line, we'll get the X and Y of that point as a tuple. If that point XY is equal to the first point on the line, we'll do nothing because we're not going to split a line based on the first point. We are going to split it based on the second point and beyond. So otherwise, we'll get the distance along the line for each point vertex along the line. We'll use the polyline function query point and distance, which will return the distance along the line that that point sits at. We'll then append that distance to our distances list. So for this linear feature, we will have a list of distances along the line that we want to split that line at. We'll set a starting distance of 0 to represent the start of the line, and we also want to account for the sequence number. So we'll set the sequence number to 1 for this line. And I'm going to iterate through a sorted list of distances and cut the line at each distance from the start distance. The start distance becomes the current distance for each iteration. So here we're saying for each distance in our sorted distances list, we're going to get a segment line. So line -1 here is current line geometry, and we're going to segment along that line from the start distance, which will first be 0.0, and then the end measure will be the first distance in the list. If the segment has no length, that means that we are at the end of the line and we'll move on to the next line. But if the segment does have a length, our start distance is the distance along the line. We want to grab our attributes for that particular line. We're then going to append the segment geometry to the segment attributes. And we're also going to append the sequence number to the segment attributes. At the very top, we have our segments list, and we are going to append the entire segment's attributes, which represents the original attributes, the new geometry, and the sequence number to that segment's list. We then increase the sequence number by 1. By the end of this section, where we are splitting the lines, we will have a segments list fully populated with a list of lists representing each segment that we want to add to the output. Now we want to create our output feature class. So we're going to use the ArcPy create feature class geoprocessing tool. We're going to create the feature class in memory initially. It's going to be a polyline. The template is the in features, so it maintains the fields already for us. If it has M or Z, we'll set same as template, and the spatial reference will be the same as the incoming spatial reference ID. we need to manipulate the schema a little. So we're going to add in the ArcFID field and the ArcSequence field. And we just need to adjust our in-field name list to account for the added fields. We're going to remove the OID field, and we're going to insert the ArcFID field at the front or the start of the list, and we'll append the ArcSequence to the end of the list. Now we want to insert our data into our in-memory feature class. So we'll use an insert cursor. So for each entry in our segments list, we're going to insert that as a row to our temp FC. Once we've inserted the data, we are going to write the feature class to disk using the ArcPy export features geoprocessing tool. Our in features is our in-memory feature class, and our out features is the out feature class from the input parameters. We'll do a little cleanup where we'll delete the temporary data in memory just as good practice. Let's head over to ArcGIS Pro and see this tool in action. Let's first take a look at the creation of the tool. Here I have the split lines at vertices with a basic license. I'll right click and go to properties. You can see here we have our parameters. So we have the input features. Feature type has been set to just allow polyline, and we have our output feature class. You can see here 0 and 1 represent the two inputs using the ArcPy get parameter as text in the script. For execution, we are pointing to where the Python script lies. We have no validations. We're not setting any environments, so this tool is good to go. Here I've added some linear data for canals in Ireland. I right click on the canals and open the attribute table. You can see here there are 16 features. We're going to split each of these features at their vertices, and each new segment will maintain the attributes of the original line plus the original feature ID and a sequence ID. I'll clear that selection and close the table, and I'm going to open up the split lines at vertices tool. I'm going to set the input features, and I'll just leave the output feature class as is. It's going to go into my default geodatabase. I'll run the tool, review details, have some messages popping up there, getting vertices, splitting lines, creating feature class, inserting data, and writing feature class to disk. I don't expect this tool to work as quick or as fast as the tool available on the advanced license, but it will do the job. Here we have used ArcPy to create this tool. You could probably recreate this tool using other libraries and speed things up a little. I'll close down the dialog box. I'll open up the attribute table for our newly created feature class. You can see there's 14,879 records. And we can see that the attributes have been maintained. And if we take a look at ArcFID and ArcSequence, you can see here that the original feature ID of 1 has, probably going to hit too far there, now 200 plus segments. There we go. It has 397 segments, so this should be the last segment of that line. I'll zoom to that there, and I'll zoom out. Now if we go back up, we can check the starting segment is all the way over here. So we have successfully recreated the split line at vertices tool that is only available on an advanced license in ArcGIS Pro. I hope you found that workflow useful. If you are using a basic license and you need to use the split line at vertices tool that's only available on an advanced license, below this video there is a link to the original blog post where you can find more details on this workflow. There's also a link below for an ArcPy course should you wish to learn more about ArcPy. And please feel free to comment below if you have any feedback or you found this video useful.